Good morning for everyone and also to Dr. Fong. Today, our group will be presenting Chapter 10 tutorial question. Before we proceed into the question, I would like to introduce myself first and my others group members. For the first one, Lee Ka-wei, he will be answering the question number 1. Second, Catherine Yap Ki-zuan, she will be answering the question number 2. Third, Abdul Azim bin Abdul Rahim, he will be answering the question number 3. Next, Tang Yuan Jing, she will be answering the last question, which is question number 4. And the last one, myself, Muhammad Farid bin Ahmad Zamri. Without wasting any time, let's look into the first question.
Good morning to Dr. Fong and fellow friends. Hi, I'm Gawi and I'm going to show you the solution for question 1. According to an estimate, the average earnings of female workers who are not union members are paid for $388 per week, and those female workers who are union members are paid for $505 per week. So 388 is our first population mean, whereas the 505 is our second population mean. Suppose that these average earnings are calculated based on random samples of 1,500 female workers who are not union members and 2,000 female workers who are union members. Further assume that the standard deviations for two corresponding populations are $30 and $35 respectively. Test at the 2.5% significant level whether the mean weekly earnings of female workers who are not union members are less than those of female workers who are union members. So we have got some information from the question where the non-union, the population mean is 388 and the population size is 1,500, standard deviation is 30. Whereas for the union, the population mean is 505, the population size is 2,000, standard deviation is 35. So let's start with the first step. State the null and alternate hypothesis. So for lower than or higher than, we always look for the alternate hypothesis. So it says that the non-union weekly earning is lesser than the union one. So our null hypothesis will be the opposite of the alternate hypothesis. The second step, select the level of significance. So our alpha is equal to 0.025. Third step, determine the appropriate test statistic. Since we have known that the both population standard deviation, so we can use the Z distribution as our test statistic for this question. So when the value is equals to 0.025, our critical point will fall on negative 1.96. So any value that exceeded on the negative side that is lower than the negative 1.96 is going to be our rejection area. And the fourth step is formulate a decision rule. Reject the null hypothesis is if the test statistic value is lower than the lower bounded critical value, which is negative 1.96. Otherwise, we do not reject the null hypothesis. The fifth step, take a sample and make a decision. So now we have to input our formula. The first population mean minus the second population mean divided square root the first variance over the first sample size plus the second variance over the second sample size. And then we input all the values that we have obtained from the question, and eventually we will come up with a z-score which is negative 106.25. So the computed value is negative 106.25, which is smaller than our critical value of negative 1.96. So our decision is to reject our null hypothesis. The final step, interpret the result. So since our computed value is lower than the critical value, so we can say that the difference of average earnings between the union and non-union members is too large. Hence, we have sufficient evidence to conclude that the mean weekly earnings of female workers who are not union members are less than those of female workers who are union members. Thank you. Next, I will pass the floor to Catherine for question 2.
Next, I'll proceed with question 2. A sample of 16 children from New York State show that the mean time they spend watching television is 28.50 hours per week with a standard deviation of 4 hours. Another sample of 13 children from California show that the mean time spent by them watching television is 23.25 hours per week with a standard deviation of 5 hours. Using a 2.5% significance level, can you conclude that the mean time spent watching television by children in New York is greater than that for children in California? Assume that the standard deviations for the two populations are equal. From question 2, they already given us all the information we needed. Like for New York, we have a sample size of 16, mean of 28.50, and a standard deviation of 4. While for California, we have a sample size of 13, mean of 23.25, and standard deviation of 5. Next, we can proceed to the first step. For the null hypothesis, our mean 2 will be greater than or equal to mean 1. While for the alternate hypothesis, the mean 1 will be greater than mean 2. For step 2, the significance level already been given from the question, which is 2.5% in percentage form. So we have to convert it to decimal point and we will get alpha 0.025. In step 3, we will be using t-value for this question because the population of standard deviation is not known, so we assume it to be equal. Besides that, the sample size are small, which is less than 30, so we use t-distribution in this question. In step 4, we have to reject the null hypothesis of the statistic value is more than the critical value. Therefore, we have to find the degrees of freedom by using the formula n1 plus n2 and subtract with 2. We will put in a value which is 16 plus 13 minus 2 and we will get the answer which is 27. To find the critical value, we have to look at the t-distribution table and then we will get 2.052. Therefore, our critical value of t-value will be 2.052. In step 5, we have to calculate the pool variance for the two samples by using the formula below, and we put in the values given and we will get the answer 20. We can find the t-value also by using the formula given, and we substitute the value inside the formula given, and the final answer we get will be 3.1440. As we all know, 3.1440 is greater than 2.052, where the t-statistic value is more than the critical value, so the test statistic will be in the rejection region. Therefore, we can conclude that there is sufficient evidence that children in New York State spend more time on average watching TV than children in California. Next, I'll pass the question 3 to my group mate.
Everyone, my name is Abdul Azim and I will present question 3. The following table gives the blood pressures of 7 adults before and after the completion of a special dietary plan. At the 5% significance level, can you conclude that the blood pressures before and after the completion of the dietary plan is different? I have highlighted the main points in the statement. For question 3, we will do the hypothesis testing with dependent samples based on the question. And there is a few steps that we have to follow. The first step is to state the null and alternative hypothesis. For the null hypothesis, there is no difference, which is the difference equal to 0, whereas the alternative, there is differences, whereas the differences is not equal to 0. The second step is the state the level of significance, which is 0.05. We will get the info from the question. Next step is select the appropriate test statistics, which is we use the t-statistics. And the step 4 is state the decision rule. And we use the t-table and we will get 2.447, and we will be reject null hypothesis if t is greater than 2.447 or t less than negative 2.447. Next step is take a sample and make a decision. So we will find the info of difference for both dependent samples and we will put into the formula. The first formula is the mean of difference. We will get 35 divided by 7 and we will get 5. For the standard deviation of the difference, and we will get 10.786. So we will find the t-value by using the formula, and we will put all the info into the formula and we will get 1.226. So the t-value is less than the critical point. Therefore, the decision is do not reject null hypothesis. In conclusion, the data indicates that the blood pressure before and after the completion of dietary plan is different. That's all from me. I will pass to the next presenter.
Thank you, Adi. So now I will continue with question. So for this question, the Lottery Commissioner's Office in a state wanted to find if the percentage of men and women who play lottery often are different. A sample of 500 men taken by the Commissioner's Office showed that 116 of them play the lottery often. Another sample of 300 women showed that 66 of them play the lottery often. Testing at the 1% significance level, can you conclude that the proportions of all men and women who play the lottery often are different? Okay, so step 1 is state the null and alternative hypothesis. The null hypothesis is proportion 1 minus proportion 2 equal to 0. This indicates that the two proportions are equal. And the alternative hypothesis is proportion 1 minus proportion 2 not equal to 0. This indicates that there is a significant difference between proportions. Step 2, state the significance level. So it is given in the question, which is 0.01. Step 3, determine the appropriate test statistic. We will use the Z distribution to approximate the binomial distribution because the sample size are relatively large. Then step 4, formulate the decision rule. So in here we have to find the critical value, which is 2.57 and negative 2.57, and we will reject the null hypothesis if Z is larger than 2.57 or smaller than negative 2.57. Step 5, select a sample, do the analysis, and make a decision. First, we calculate the computed value by using the formula x1 minus x2 divided by n1 minus n2 and get the answer 0.2825. And then we calculate the z value by using this formula. Before we calculate, we need to identify the value of P1, P2, PC, N1, and N2. So P1 we can calculate by using this formula x1 divided by n1 and get the answer 0.32. While for the P2, we also can use the percent formula and get the answer 0.22. PC, we already got the value, which is 0.2825. N1 is the man sample, number of man sample, which is 500. And N2 is the number of woman sample, which is 300. And we substitute this information into the formula and get the Z value, which is 3.049. So the computed value of 0.2825 is in the area of the rejection. Therefore, the null hypothesis is rejected at the 0.01 significance level. Step 6. Interpret the result. We have sufficient evidence to conclude that the proportions of all men and all women who play the lottery often are different. Thank you.
Okay, that's all from our group. Thanks for watching. Now we'll be proceed into the Q&A session.